Welcome to Easy Limo Learning Simplified. My name is Eric. I'll be taking you through this topic area, and for this lesson, we're going to look at surface area of prisms. So we want to see what a prism is and how we are able to find the surface area, what we are calling the surface area. What is it? What is this thing we are calling the surface area? So what is a prism and how do you find the surface area of a prism? You know. So we have also a few questions that will be helping us with illustrations on how that can be done. And then at the end of the lesson, we'll be having some assignment, some questions in the form of assignment just to help you practice on what you're going to discuss during this lesson. So a prism is a solid with a uniform cross-section. So you can see here, like this is the cross-sectional area. So this is supposed to be uniform as you move along that length, you see. We call it uniform cross-section. You can also see this one here has got a cross-sectional area here that is circular, but that is uniform as you move downwards. Like that shape, this shape that you can see here is uniform as you move downwards. So such a shape or such a solid that assume that kind of a shape is what we're calling a prism. So the surface area of a prism is given by the sum of all the area of the surfaces. Like this one here will work out this surface, the other surface, there is another one here, there is another one here, there is another one down here. So you add all of them and that is going to give you the total surface area. When it comes to this, we have the curved surface, this one here, and we have the flat surface at the top and another flat surface at the bottom. So for cylinder, this one here will be looking at the area of the flat surfaces plus area of the curved surface. The same applies to this. It has very many surfaces. We have this one, this one, this one, this one here. So the surfaces are very many. So you have to find all of them. So you find all the surfaces as you add. So these are just some of the prisms. The prisms are very many. Now the prisms are normally named based on the cross section. You know, the shape at the cross section. Like this one can be called a triangular prism because the cross section here is triangular in shape. See, this other one here can be 1, 2, 3, 4, 5, 6 of hexagonal prism because the cross section here is a hexagon. So normally they are named based on the shape that is assumed by the cross section. So if the cross section here is rectangular, you can talk of rectangular prism. If it's a square, square prism, and so on and so forth. So you want to see how you can find the area. So we have examples here just to help us with illustrations. Find the surface area of a building block. You know, a building block measuring 9 centimeters by 12 centimeters by 4 centimeters. So let me try and sketch. So I have a building block here. So I'm trying to sketch the building block. So this is our building block. So this is our building block. Let me try and okay. So that's our building block. So what we will do is that we love to, so the measurements are given. So our measurements are 9. So this is 9 centimeters. This is 12. And the other one is 4. You see. So finding the surface area here, you'll have to find the surface area of the bottom, surface area of the top, surface area of this one here, surface area of the other one. So there's the other one on the other side. So what you will do, you'll identify maybe 3 pairs of similar faces. So like this face A here has got a similar face on the opposite side that is the same. So I can call this area A, and then you will multiply this area A by 2 to give you the sum of the two faces. That is this one here and the other one on the opposite side. We also have this face here. Maybe I can call it B. There is another one on the opposite side that is of the same, of the same dimension. So you can find this B and then you multiply by 2. And then finally there is area C at the top, and then area at the bottom is also of the same. So capital C will be the product of the two. So I do, of course, all of them are rectangular in shape. So I have area A should be equal to length times width because they are all rectangular in shape. So length could be 9, and then width would be this one here, which is also 4 centimeters. So you multiply by 4, and that is 36 square centimeters. So our area, that is the two, this one A and the other one on the opposite side should be twice A, which is 2 times 36, and that is supposed to be 76. So capital A here should be equal to 72 square centimeters. Then I move to B. Again, should be length times width. So length is 12, and then you multiply by width, which is 4, and that is going to give us 48 square centimeters, and then you have to multiply it by 2. So capital B should be 2 of these. So 2 by 48, and that is going to be 96. So that is going to be, so B here should be 96 square centimeters. Then C, which is at the top, should also be length times width. So length is 12 and width is 9. No, this length here, this length and the other length, they are the same. Even this one here, you see. So width is 9. So we have 12 by 9. So that is 108 square centimeters. So that capital C, you now multiply that by 2 because there is also one at the bottom. So 108 by 2. So what is that equivalent to? So that is 8 by 2 is 16, 6 carry 1. 0 by 2 is 0 plus 1 is 1, and 2 by 1 is 2, so 216 square centimeters. So now we have the total area that we are looking for. Maybe A subscript T here should be equal to A plus B plus C, area A plus area B plus area C. So that is going to be, the first one was 72. That is A total, 72. And then you add 48. And then now 216. So what do we get? So 216. So 216. Let me start with 72, but now I'll write it as 0. I'll write it as 072. And then the other one is 048. So you add, this is 0, 11, 12, because we had carried 1 from here. So 2 carry 1. And then 0 plus 0 is 0 plus 1 is 1. Then now we add 216, so that is 633. So the total area, surface area, should be 336 square centimeters. Okay, good. So we have another good example here. So you can find this area, the other one on the other one on the other side, and then there is this one on this side, and then there is the other one on the other side. So tentatively, you can use the formula if you're finding the area, 2 times cross-sectional area because cross-sectional area is this is the cross-section, there's another one on the other side, that's why you're multiplying by 2, plus perimeter of cross-section, you take the perimeter of the cross-section and then you multiply by the length. See, because now the reason why we are taking the perimeter, it means I need to, if getting this other face here, we'll have to multiply this one by the length. I will have to multiply this by the length to find this, and I have to multiply this by the length to get the base. So you realize that in all of them, you'll be multiplying all this by the length. So you can just add all of them and then you multiply by the length once. That's why you're finding the perimeter and then multiplying by the, finding the perimeter and then multiplying by the length. Because the length times 5, length times another 5, length times another 5. So in short, instead of multiplying one by one, we can first of all add all of them and then you multiply by the length once. So this formula can help 2 times cross-sectional area and then perimeter of the cross-section times the length. So you have to identify the cross-sectional area. Like in this case, cross-sectional area is triangular, isosceles triangle. So the area now in this case is going to be 2 times. So a half times base times height. So base is 6, and then height is 4. Then perimeter of the cross-section is 6 plus 5 plus 5, and then you multiply this by 15, which is the length. So what do we get? So this is 2 into, so 2 here, 1, 2 there, 3, and 3 by 4 is 12. Plus 6 plus 5 is 11, plus 5 is 16, 16 by 15. So this is 24 plus 16 by 15, 16 by 15. So 16 by 15, what do we get? So 16 times 15, 5 by 6 is 30, 0 carry 3, 5 by 1 is 5 plus 3 is 8, 0, 1 by 6 is 6, and 1 by 1 is 1. Fill up the spaces left using zeros, add the two products. So we have 0, 14, 4 carry 1, and then 2. So that is 240. So 240. So we have 24, and then you add 240. So if you add this, what do you get? You get 264 square centimeters. Finally, we have this. The area, the surface area of a triangular prism of length 25 centimeters, given that the cross-sectional area is an equilateral triangle of side 6. So we just need to find the area of the cross-section times 2, and then perimeter of the cross-section times the length. That is easy. If you master that formula, then it becomes relatively easier. So let me get the perimeter, the cross-sectional area. So I'll use Hero's formula. So it is triangular, the cross-sectional area is triangular, and it's an equilateral triangle of side 6 centimeters. So let me find the area first. Let me find this area first. So this area will be given by this formula, S into S minus A, S minus B, S minus C. such that S is given by half of the perimeter. So S will be half of what? 18, which is equals to 9. So it means my area is going to be square root of 9 into 9 minus 6, 9 minus 6, and 9 minus 6. So that is going to be the square root of 9 times 3 times 3 times 3. So that is the square root of 9 times 27. So 9 times 27, what is it? So 27 by 9. 9 by 7 is 63, 3 carry 6. 9 by 2 is 18, plus 6 is 24. So 243. So we have the square root of 243. So you can use tables to find the square root of 243. We have done that before. So if you use the tables to do that, you'll find 15.59 as that is square centimeters. So that is the area of the cross section. So our formula for total surface area will be twice the cross sectional area plus perimeter of cross section, and then you multiply by the length. So this is 2 into 15.59, and then you add perimeter of the cross section is already 18. You multiply by the length. What was the length? 25. So I'll start by multiplying 15.59 by 2. So 18, 8 carry 1, 10 plus 1 is 11, 1 carry 1, 0, 2 by 5 is 10 plus 1 is 11, 1 carry 1, and 2 by 2 is 2 plus 1 is 3. So 31.18. That is if you multiply 15 by 2 and then 18 by 25. So again, you multiply 18 by 25. What do you get? So 18 by 25. So 5 by 8 is 40, 0 carry 4, and 5 by 1 is 5 plus 4 is 9. 0, 2 by 8 is 16, 6 carry 1. 2 by 1 is 2 plus 1 is 3. Fill up the spaces left using zeros, this multiplication, this addition. So this is 0, this is 5, and this is 4. 450. So you have 31.18, and then you add 450. So 450. So let's try and add the two. So 450.00. I'm writing 00 because the first one has two decimal places, and then 31.18. So if you add this, this is 8, this is 1, this is 1 again, this is 8, and this is 4. So we have the total area of this prism being 481.18 square centimeters. So we have a few questions here about two, just to help you practice on what you've been learning through this lesson. You can attempt. When done, you can be posting feedback on the comment section. We'll be able to look at them and give feedback in the due course. Otherwise, that marks the end of the lesson. Until next time, goodbye.